Hello! Your geometry lesson for today from Chapter 1, Essentials of Geometry, is Section 1.5. I will be able to use angle-pair relationships to solve problems. Go ahead and title your notes 1.5 and list the learning target before moving on to the next slide. As we learn about different angle pairs, you'll want to set up this table in your notes. It should have 3 columns, one for the term, one for the definition, and one for the picture, as well as 6 rows, the row at the top, and then for the 5 terms, adjacent angles, complementary angles, supplementary angles, linear pair, and vertical angles. Go ahead and pause the video here while you set up the table, and then resume to learn about the definitions. Our first definition is for adjacent angles. Adjacent angles are any 2 angles that share a common vertex and a common side. Here, our adjacent angles are A and B. Another way of thinking about adjacent angles is they're any 2 angles that are neighbors with each other. So A and B are neighbors with each other because they share this side in common as well as the common vertex. Complementary angles are any 2 angles that add up to 90 degrees. So the formula for complementary would be to take one angle plus the other angle, and they must add to 90 degrees. Here, I've got 2 angles C and D. If I were to move angles C and D together, you could see that together they look like they should add up to 90 degrees. In fact, we could even draw our 90-degree right angle square in the corner to show that together C plus D should add up to a total of 90 degrees. Next, we have supplementary angles. Supplementary angles are 2 angles that add up to 180 degrees. For example, in the picture, angle E and angle F. The formula for supplementary is to take one angle plus the other angle, and they should add together to be 180. If I move angles E and F together, I can see that together they would add up to 180 degrees, or a full straight line. There's no symbol for a straight line like there is for a right angle with the square, but we could do something where we show an arc mark like this to show that we're talking about the entire angle E plus F together. Adds up to 180. Next, we have a linear pair. A linear pair is 2 adjacent angles that form a straight line. Notice that a linear pair and supplementary are very similar, but in a linear pair, the 2 angles must be neighbors, so they have to already share a side, like G and H do, as opposed to E and F, where I had to move them together to show them adding up to 180. Our last angle pair are vertical angles. Vertical angles are 2 angles with sides that form 2 straight lines or an X. Vertical angles are equal in measure, so whatever angle J is, angle K will equal the exact same thing. Vertical angles can be left and right, like this, or top and bottom. There would be another pair of vertical angles here, the top one equal to the bottom one. These are our 5 different types of angle pairs that we'll study in section 1.5. Pause the slide here to make sure you have the definition of each and the picture before moving on. Using our angle pairs, we're going to go through a few different examples. In example 1, we're just solving to find a missing angle. Here I can see I have a pair of complementary angles because I have my square that adds up to 90 degrees. So if I know that angle, whatever angle A is, plus 62 needs to add up to a total of 90 degrees, all I need to do is 90 minus 62 to see what's left over for angle A, and 90 minus 62 is just 28 degrees. So A, the missing one there, would be 28 degrees. Over here, I can see that A and 101 are on a line together, making them a linear pair and also supplementary. So I know that added together, they need to add up to 180. So I can just subtract 101 from 180 to see that what is left over is 79 degrees for angle A. Make sure you have both examples, the complementary angles and the linear pair that add up to 180, written down for example 1, and then move on to example 2. In example 2, we're looking at an angle pair and trying to solve and find the value of x. This angle pair, where I have two straight lines that form an x and then two angles, one on top and one on the bottom, these are angle pairs that we call vertical angles. We know from our definition that two vertical angles are always equal to each other. So in my drawing, I'm going to show with an arc mark here and here that these two angles are in fact always equal to each other. So I can put the same mark in them. So let's go ahead and write and solve an equation to find the value of x. Since we know that these two angles are vertical and must be equal to each other, we can write the equation 5x plus 3 equals 3x plus 51 and set them equal to each other. Now, all we need to do to solve for x is get x alone. I like to keep my x's positive, so I'm going to subtract 3x from both sides. On the right side, that'll cancel, and I'm just left with 51 equals, on the left side of my equal sign, 5 minus 3x is 2x, plus 3 equals 51. Subtract 3 from both sides, and I get 2x is equal to 48. And finally, my last step will be to divide by 2, so that I get x is equal to 24. We can go ahead and plug that into our answer to make sure that we answer the question and find the value of x. Now, one thing it does not ask us to do is plug in and find the value of the angles. However, I could do that to check my work. I could take 3 times 24, which should give me 72, plus 51, and 72 plus 51 adds up to a total of 123 degrees. When I plug in for the top part, 5 times 24, that should give me 120 plus 3. Notice that my vertical angle on top is also equal to 123 degrees, so I can tell that I did the problem right since my two vertical angles end up being equal. Pause here to finish copying down the picture or the equation before you move on to example 3. All right, so for example 3, we have a similar setup. We have an angle pair and we're trying to solve for the missing variable, in this case b. This particular angle pair, since they are on a straight line together, we would call them a linear pair. We know that every linear pair adds up to 180 degrees, so the equation that we could use to solve for b is 9b minus 8 plus the other angle, 98, needs to add up to a total of 180. The first thing I'm going to do before I move anything around is to combine like terms. So I have negative 8 or minus 8 plus 98, that makes 90. So I can simplify to 9b plus 90 equals 180. Subtract 90 from both sides, and I get 9b equals 90. 180 minus 90 is just 90. Divide by 9 on both sides, and b equals 10. So let's go ahead and write that in for our answer that we've solved for our missing variable. B is 10. Just like the last one, if we want to check our work, we can do 9 times b, 9 times 10, which is 90, minus 8 gives us 82. And indeed, 82 and 98 does add up to 180 degrees, so then I know I did this problem correctly. Let's take a look at one final example with angle pairs. So here we have example number 4. Angle A and angle B are complementary angles. the measure of angle A is 2x plus 18 degrees, and the measure of angle B is 6x plus 8 degrees. The first thing you should do whenever you're given information like this is to draw a picture if one is not provided for you. So the very first thing I would do here is draw a picture of my two complementary angles. So I'm going to go ahead and do that. And when you draw that picture, you should get a picture that looks something like this one. Oh, maybe I can't make it appear. All right, I'll just draw you a picture by hand. So your picture should look something like this. Let me get a pen here to draw you a picture. So your picture, we've got two complementary. That means that they add up to 90 degrees. And you know that one of the angles measures 2x plus 18, and one is 6x plus 8. Since we don't know what x is, I'm just doing my best to guess that the one that's 6x plus 8 is bigger than the one that's only 2x, but your picture is just to get a general idea of what's happening here. So I've got two angles that add up to 90 degrees because it said they're complementary, and that's what complementary means. So let's go ahead and write our equation that I know A plus B, since they are complementary, when I put them together, will add up to 90 degrees. Before we start solving, we're going to want to combine the like terms of 2x and 6x to be 8x. And we're also going to want to combine the like terms of 18 and 8, which makes 26, and set that equal to 90. Now we can start to move stuff around from each side, first subtracting 26 from both sides, which will give us 8x alone on the left side equals 64 on the right side. And our last step will be to divide both sides by 8 to get x alone, to see that x equals 8. I can write that down, but the question itself needs to be answered still, which is to find the measure of angle B. So I'm going to go plug in for angle B. Notice that angle B was 6x plus 8. So if angle B is 6x plus 8, let's go ahead and plug in. We know x is 8, so 6 times 8 gives us 48, and 48 plus 8 gives us 56. So therefore, the final answer to this problem is that the measure of angle B is equal to 56 degrees. So you've seen 4 different examples about angle pairs. I want to finish today's notes with talking about how to interpret a diagram. Pause here to copy down both diagrams, taking special care if you have different colored pens or highlighters or markers or colored pencils. You may want to put the things in red in the second diagram in a different color so that you can specifically see the difference between the two pictures. What I want you to notice here in these diagrams are specifically how much more information we can get by the markings that are in the diagram with red versus just this diagram on the left. While we know several things about the diagram on the left, we know more specific things about measurements for this diagram on the right. Let's take a look at those specific things first. Because of this diagram on the right, we know that A to B and B to C are equal. The way we know that, the way we know those two distances are equal, is because of the tick marks. So because of those tick marks right here at AB and right here at BC, we know that those two distances are going to be equal. The only way we can know distances are equal is from tick marks. We can never assume it just based on looks alone. Next, we have arcs at DBE and EBC, so we know those two angles are equal because they have the same arc marks. That's how we show equality in angles. And lastly, we know that A to B to D is a right angle. The way that we know that is from the square in the corner of that right angle. So notice because of each of those marks, we were able to know something specific about a measurement of angles or segments. Let's take a look at what we know about the picture on the left. We know lots of different things here. We can assume that all the points are coplanar, that they're all lying on the same flat surface. We can know that A, B, and C are collinear. They lay in the same straight line along the bottom of the diagram. We know that all of these rays intersect at point B. We can see there's a B to A, B to D, B to E, and B to C. We know that the angles DBE and EBC are next to each other, and that ABC is a straight 180 angle. However, what I really want you to pay attention to is the difference between on the left, where we know very generic things, versus on the right, where we know very specific things about measurements when we have tick marks to show equal segments, arc marks to show equal angles, or a square to show a right 90-degree angle. This is the end of your 1.5 geometry notes. You are now ready to move on and do the 1.5 homework assignment.